And then we convert this into matrix. X. And then we solve. By this we mean that we find the eigen values of A and the eigen. So the lambdas and this is like the other flow. So like in these 40 minutes again we're gonna quickly take one example and do all the steps. So suppose we have y triple dash plus 2 y double dash plus 3 y dash equal to solve. That's a good question. No, it can be not equal to 0. However, we are not gonna cover this part because it's gonna include again variation of parameter and undetermined coefficient for matrices, and this is a little bit involved. I might talk about how we're gonna represent it in here because that's important actually. Like how we're gonna write it in a matrix format. But for now, let's just talk about the homogeneous cases. Solve using matrix. So again, this is a higher order differential equation, and we need to convert it into state space, and then convert state space into matrices, and then try to find the eigenvalues and eigenvectors, and then write it. So, what is the order of this differential equation?
Second.
3. How many states we should take? 3. 3 states. So the number of states always equal the order. This seems easy, but it always confuses the students. Okay? The number of states are equal the number of the order of the differential equation. So this is 3, so we should have x1, x2, x3. Those are the 3 states. And we normally give them y dash, y double dash, sorry, y dash, and y double dash. And then, so those are the states. States means we give a name to every measurable quantity in the system. We have a system, we have measurable quantities. Like in this system, the measurable quantities is y dash, and y double dash. We will give every one of this a name. These names happen to be x1, x2, x3. You could call them Ahmad, Muhammad, Mahmoud. Whatever, 3 different names. And the name will represent a state. So this is the state. So, and these states has to evolve. Like they have evolutions, they have changes. So we need to introduce this evolution. So x1 dot equal y dash, x2 dot equal y dash, x3 dot equal y triple dash. And then we need to eliminate the y's from the x. So we need to have everything in terms of x. So what is y dash? We give it a name before. So it's x2. What is y dash? What is y double dash? x3. What is y triple dash? We get it from there, which is minus 2 y double dash minus 3 y dash. But we know what is y double dash? Right?
Yes.
So that means the system is x1 dot equal x2, x2 dot equal x3, x3 dot equal minus 3x2 minus 2x3. Right? This is the first, we done this is done, which is converting the system into state space. Now, we need to build this into matrices. Matrices is always like this. We need to convert it into something equal something times something. We call this x dot x, and this is a. So what is x dot? We list all the states we have here, and these are the states. So this is x, and this is x dot. Here is the matrix that has the connect these equations together, which is in this case will be
0,
0, 1, 0,
0,
0, 0, 1.
0, negative 3,
Yes, actually, yes.
0, negative 3, negative 2.
Okay? So this is called the dynamical matrix or the A matrix. Or what we need to do is to, now we done this step as well. So our system can be written as, so the y double dash plus 2y double dash plus 2y dash equals 0 now is written in terms of x dot equal a times x. Okay? And the A matrix is this one. In order to solve, we need to find the eigenvalues and eigenvectors of the matrix A. So the next step is to find the eigenvalues and eigenvectors of A. A in this case is 0, 0, 0, 1, 0, 0, 1, minus 3, minus 2, So the whole problem becomes now an eigenvalue problem. What is an eigenvalue problem? We said that last time. We said an eigenvalue means that the matrix A can be multiplied with a vector V. It gives us the vector V again. So V is a group of eigenvectors or a group of vectors that when we operate A on V, it gives us the same V back, just multiplied by a constant. We call this constant an eigenvalue, and we call the vector as an eigenvector. Okay? So again, the vector space is like infinitely large, like it has infinite number of vectors. Every time we multiply the A on a vector, it gives us another vector, it gives us another vector. Except group of vectors, in this case 3 vectors, because this is 3 by 3. There are 3 vectors that when you multiply the A, when the A operates on these vectors, can you please close this laptop, or you can, excuse me, you either close the laptop or take the laptop and watch whatever you're watching outside. When we operate with this matrix on this, particularly 3 vectors, we get them back by they just multiplied by a constant. That constant could be any number, or a number we call it an eigenvalue to this matrix, and this is called the eigenvectors of this matrix. The importance of these, think of it as we're living in the 3D space, for example, this space. Like, and imagine all the vectors that you can draw here. There's millions of them, right? And there is an operation that when it operates in one vector, it gives you another vector in the space. Like this vector, this vector, this vector, this vector. Except there are 3 vectors, maybe the one on the x-axis, the one on the y-axis, the one on the z-axis. They define the space that this matrix lives in. So these 3 vectors, they kind of the main principal components. When A operates in them, it's just extend them. It doesn't change their direction. And this is what we call the eigenvalue problem. And all what we need to do is to find the A's, is to find those vectors and those values. how to do that. It's called the eigenvalue problem. The eigenvalue problem is always like this. A V minus lambda I V equals 0. We can take the V, we talked about that last time. A minus lambda I V equals 0. So we can start always with this eigenvalue problem or this equation. This equation will give us, it will only be true if determinant of A minus lambda I equals 0. And this will give us, it should give us the lambdas that satisfy this. So let's just substitute. What is the A matrix? We have it. The lambda, this is what we're looking for. The I is the identity matrix. So the A minus lambda times I, it will give us lambda 0, 0, 0, lambda 0, 0, 0, lambda, which will equal to minus lambda 1, 0, 0, 0, 0, 1, and then 0, minus 3, minus lambda minus 2. Okay? And then we need to find the determinant of these. So that
we expand the first column.
minus lambda 1, 0, 0 minus lambda 1, 0, minus 3, minus lambda minus 2. So we could use any row or any column. Well, it's better always to use the one that has more zeros, which is the first column. You could use the first row, but the first column will make it more efficient or quicker. So we're going to use this guy here, so which will equal to minus lambda. We're going to imagine that we removed its row and its column, so minus lambda 1, minus 3, minus lambda minus 2. And that's it, because the others will be 0. Because 0 times 0 times, so that will be 0. So here will be, again, minus lambda times minus lambda minus 2. Please be careful with the signs here. Plus 3, which will be,
Lambda square. Plus
am I doing right? So minus lambda here.
AD minus BC.
Yes. So this will be minus lambda square minus 2 lambda plus 2 lambda plus 3. Right? Yes.
What is the total?
Sorry?
Doesn't total?
No. Well, we need to find the lambdas. We need to factorize.
Yeah, so
If lambda is already factored, that's very good actually. Instead of multiplying and then trying to solve a third order polynomial. So here is minus lambda times lambda plus 2, lambda plus 1. Right? Because we can do mod 5 3 for this one. Mod 5 3 lambda squared plus 2 lambda plus 3. It gives you minus 2 minus 3 or lambda plus 2 lambda plus 3. So which will give you that lambda will equal to 0, lambda will equal minus 2, lambda will equal to.
Minus 1.
These are our 3 eigen values.
Doctor, I get complex numbers.
High 3 by 3, man.
No, I mean the last step.
Wait, wait.
The complex and the
No, well, I meant this is 3, this is 2. Because I did not yet talk about the complex case. So this is 2, 3. Okay? Yeah, just because we did not yet talk about the complex case, so let's keep in the real case. Okay? So these are the three lambdas. So this will be 2, this will be 3. Okay. So these are the three lambdas, or those are the three eigenvalues. So we have the three eigenvalues. We need to find the three corresponding eigenvalues. From where? From A minus lambda I times V equals 0. The eigenvalue problem that we solved. This one here. How we're going to do this? We're going to choose once lambda equals 0, another time lambda equals -2, lambda equals -1. Okay, so lambda equals 0 means we're going to substitute here in this lambda equals 0 and then try to find the v. So where we substitute, again, you will always find this part you calculated before. Lambda minus I, A minus I lambda, it's always this one, this matrix that you got here. Okay? So,
have 0.
which is, we're gonna put lambda equals 0, it will be
0,
0,
1,
1,
0,
0,
0,
0, 0, 1,
0, negative
0, negative 2,
2,
negative 3. V1. The other one, okay, equals 0. So we need to we need to solve to find the V1. The V1 we have to make it mu1, mu2, mu3. So 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, minus 2, minus 3, mu1, mu2, mu3 equals 0. So, well, we need to make more zeros in this matrix. Remember the last time when we said like the row operation? The row operation means like we can multiply one row with something and add it to the second row or the third row. So we hope that if we can make this 0, can we make this 0?
Yes.
Multiply the first row
By minus.
by 2 and add it to the second row. So multiply, so it will be 2 R1 plus R3, which will give us 0, 1, 0, that will stay there, 0, 0, 1, we didn't touch this one, but this one will be 0, 0, negative 3, because the 0 added to it, there is no change. So here is still mu1, mu2, mu3. Can we make this also 0? Multiply the second row with 3 and add it in the third row. So 3 R2 plus R3.
0, 1,
0, 1, 0, 0, 0, 1, 0, 0, 0. U1, U2, U3. Can we make any other things 0? No. In here you can't, even if you wanted to, you can't. You cannot make this 0 because it's up and down are zeros. You can't, whatever you add is not gonna affect that. Similarly here as well. So this is called actually the reduced row column matrix. This is the maximum that you can reduce. For people who did linear algebra, they should know this very well. Yes?
Sir, you are forcefully making the third row redundant?
It will always, there will be always one row that it's zeros.
So you are forcefully making it.
Yes, yes. Because this will, well, we make this so that we can, when we find the relationship between mu1 and mu2, mu3, it will be easier. But you could actually, from here, get 3 equations, try to solve them, but that would be like too much. Doing these operations will make us here realize that obviously all of this equal
To 0.
zeros. So we're gonna multiply this times this.
No, doctor, the last one shouldn't be equal to 0.
No, all of them equal to 0. So multiplying this times this, the last one has to be equal to 0. Because zeros times anything is zeros has to equal 0 on the other side.
Doctor, I'm pretty bad at this.
But you multiplying this times this equal this. It's 0 times 0 times 0. So here we multiply the first row times the 3 mu's. So this will mean
mu1 is equal to
mu2 equal to 0. Right?
Yes.
أنا بضرب الصف ده in this column. 0 times this is 0. This times this is 1. This times this is 0. So mu2 equal 0. So mu2 equal 0. And then the second row will say what? u3 equal 0. Why not? We multiply this row in this column. 0, 0, mu3 equals 0. So that's the mu3. نعم؟ هي واحد مضروب في ميو 3 is ميو 3 بتساوي بقى في الناحية التانية 0. اوكي؟ الصف الثالث هيدينا أي معلومة؟
لا.
هيدينا صفر بيساوي صفر. Thank you. That doesn't add anything. But even those are very enough. Why? Because now, what was the V? mu1, mu2, mu3. What is mu1? We don't know. What is mu2?
0.
What is mu3?
0.
Can we take mu1 as a common factor now?
Yes.
1, 0, 0. And this is the eigenvector. Okay? So we said last time we don't really care about this component as far as multiplied with the whole vector. Because we're just interested in the vector itself, not the magnitude of the vector. So that's V1. So we have V1 now equal 1, 0, 0. Let's repeat the same process, but when lambda equal minus 1. So let's take the matrix again. This matrix. We're going to have minus 1 that will be 1, 1, 0, 0, 1, 1, 0, negative 2, negative 2. Right? Because minus 3 plus minus 1, so it will be 1. So this is multiplied by, again, mu1, mu2, mu3, that should equal to 0, 0, 0. All what I did, I took the matrix, substituted lambda equal minus 1, that's all. Now, is there something that we can make zeros here? Yes, we can multiply the second row with 2 and add it to the third row.
Yes.
So, this will be 2R2 plus R3. One, 1, 0, 0, 1, 1, 0, 0, 0.
Doctor,
Yes.
why did you choose 2?
Because my aim is to make this 0. What is the number? If we multiply it with 1 and add it to this, will be 0.
2.
Okay? Is there, can we make more zeros?
R1 minus R2.
Yes, R1,
Minus
or
2.
multiply R1 with minus and add it to the R2. That's easier.
Okay.
So, negative R1 plus R2 will be 1, 1, 0, 0, 0, 1. Because there's nothing is affecting that 0, 0, 0. and this is multiplied by mu1, mu2.
طب ده
This would be negative 1
عشان باخد نيجاتيف فوق ما عندك كله له
معاك حق. صح انا كده غلطت. وكده ده مش هتبقى الاوبريشن، انا برضه بقول فيه حاجه مش مظبوط. صح ليه؟ this is I did this by mistake. So when we multiply this with negative and add it, this will become negative 1. So we're not adding new, actually we're removing 0 but we're adding another thing. So we should either write here minus 1 or we've been satisfied with this one. As far as we have one row zeros, actually you could work with that.
Do R2 minus R1.
You're gonna create something here. Again. So you're adding something and adding, you're removing something and adding something else. So we could just work with this one. What I mean by work with this one, recreating the equations. What do we mean creating the equations? Multiply this times this. So this will give me mu1 plus mu2 equal 0. What is the second equation? mu2 plus mu3 equal 0. So from this, what would be mu2 minus mu1? No, we need to, both of them have mu2 as a common factor, so let's do the opposite. So mu1
minus mu2.
mu1 equal minus mu2, mu3 equal minus mu2 as well. So this means that the v, which is mu1, mu2, mu3 equal negative mu2, negative mu2. I'm doing all of this to make them in like depending on one mu. So now I can take that as a common factor. Negative 1, 1, negative 1. And this is our second, so our second v. Okay? Well, we need to find the third v as well. Same stuff. What is the matrix? So 2, 1, 0, 0, 2, 1, 1, 0, negative 2, negative 1.
Yes, minus 1. بيحاول يقول البندرات.
مش عارف مش عشان طلعت مرة يعني أحب لا
ودي يطلع غلط
عادي عادي. Okay, so we need to again. Can we make something zeros?
R2 plus R3
Yes.
We can multiply the second row with 1 and add it to the third row. It's gonna make it zeros immediately. So 2 R2 plus R3. Yes, R2 is R2. So this will be 2, 1, 0, 0, 2, 1, 0, 0, 0. And I guess this is enough. We can recreate the equations now by multiplying this times this. So 2 mu1 plus mu2 equals 0. And then 2 mu2 plus mu3 equals 0. Here we can
U2 equal لا
U1
U1
1 equal negative نص mu2 and mu3 so which means that the V نعم This is 3, this is 2. Right?
هتبقى نيجاتيف 2 ميو 2 ليه الهاف؟
Okay.
ليه الهاف بتاع ميو 3؟ يعني انت جيب ميو 3 بتلاتة ميو 2.
Yeah.
طيب وات
Oh, it's it's 2. It's negative 2 على طول. It's negative 2 على طول. Okay. So mu1 I guess أنا sorry. mu1 is negative half mu2 and then mu2 itself and then minus 2 mu2 which is take mu2 as a common factor, negative half, 1 and negative 2. So what was the original problem? It was a differential equation that we turn it on into a state space model, and then the state space model was turned on into a matrix format, and then the matrix we try to find the eigenvalues and eigenvectors. This take a little bit of time, but finally we have the A has lambda 1 equals 0, lambda 2 equal minus 1, lambda 3 equal negative 2, V1
1 0
1 0 0, V2 was what?
negative 1 1
Negative 1 1 negative 1, V3
negative half 2.
So we have the 3 lambdas and 3 eigenvalues. Eigenvalues and eigenvectors. So now that means the solution, which is x t c1 v1 e to the power lambda 1t plus c2 v2 e to the power lambda 2t plus c3 v3 e to the power lambda 3t, which is you just say c1 1 0 0 e to the power 0, so just 1 plus c2
لا مش صح صح
هي ترى فيها
and this is the x of t. Where the x of t is, what is the x of t in this case? What is this x of t? The solution, but why?
It has YC on the bottom.
The equation has y double dashes and y dash, so we should get the solution in terms of y. Actually, the x is oh, this is t. The x of t is a vector of x1, x2, x3, which is basically y dash.
واي داش
هي
ما في داش يعني ما في واي
كان اكس اللي عليها من الطريق.
طب التريبل داش وين راح؟
وصل الطبق دكتور
ليش في اكس 1 و 2 في
لا في التريبل
احنا بنشتغل في 3 داشز، فالتريبل داش هي في اخر وقت هي ما بتبقاش موجودة. في المسائل اللي حليناها المره اللي فاتت كانت دبل داش بس، عشان هي كانت دبل داش بس المساله كانت بس دبل داش، انما هنا 3 داشز. ف this is the ones that we have. Okay.
ركز.
Okay, so this is an example of a 3 by 3 matrix. We've done the eigenvalues, we've done the eigenvectors. You might expect something like this in the exam in 3 distinct eigenvalues. What I mean by 3 distinct eigenvalues, الثلاثة values مختلفين عن بعض, real مختلفين. Okay? If they are, 2 of them are similar, then situation become quite messy. So we're not gonna take the similar in the 3 by 3 case. So what's left really, which we're gonna finish inshallah like in the first lecture next week, is that when A is 2 by 2 or second order differential equation, but lambda 1 equal lambda 2, lambda 1
Of X.
and lambda 2 are complex. Okay? So these are the terminology exactly the same. We're gonna find the eigenvalues, the eigenvectors. The last step is writing the solution is gonna be different. Remember when we multiplied by t, and then we like the complex case we say e to the power blah 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 and times cosine and sine. It's very simple. Okay, but the terminology is exactly the same. Finding the eigenvalues, like convert into state space, convert into matrices, and then find the eigenvalues, find the eigenvectors. When the eigenvalues are both equal, then you're gonna find only one eigenvector, because the other one will give you the same eigenvector. In this case, you're gonna do like small variations. We're gonna talk about that next time. And in case of complex, the same thing.
But in the exam we get third order differential equation. We have to know that for a fact the eigen.
Yes, there will be distinct difference. Or at least have 3 distinct
That's
eigenvectors.
simplification.
That's the main point. Okay? Do we take the quiz before Eid or after Eid?
After it.
Before.
Because it takes 4 quizzes.
Yes.
لا الكويز الرابع هناخده بعد الامتحان. في الصيف ان شاء الله. انتوا كده كده هتاخدوا 3 كويزات في الصيف.
أنا وش أنا كوز دكتور؟
نعم. حاجات بناخدها هنا. هيكون عن ايه يعني؟ هو خلص لابلاس، هو هيجي لهم كويز في لابلاس وانتوا هيجيلكم في المنهج.